This is Module 16, Section 10.2, where we're going to discuss rational exponents and radicals in more detail, starting with rational exponents. Radical expressions can also be written as rational or fractional number exponents. By definition, the nth root of a to the m is equal to the nth root of a raised to the m power, which is equivalent to a to the fractional exponent m divided by n. Now here's what I want you to notice here. Notice that this term, written with fractional exponents, compares to the radical form like this. Your denominator of your fractional exponent is actually the root or the index of the radical expression, and your numerator of your fractional exponent is the power that's associated with the base in radical form. And also notice that that power of m can be written underneath the radical sign with the base, or it can be pulled out separate and taken as a step after the initial root is taken. So that m can be shuffled back and forth between the sign and outside of the sign, depending on what's easier for your particular problem. So we want to practice that using these examples. Let's say the instructions said, use radical notation to rewrite each expression and simplify if possible. So let's start with this example. We've got a term written with a rational number exponent, 8 to the 1/3 power, and we want to use radical notation to rewrite that expression. So again, radical notation always has a radical sign in it. The denominator of your fractional exponent is always the root or the index that you're taking, and then the base, which is base 8 in this case, we'll take the numerator, and you can either put that power of 1 underneath the sign with the 8, or if it makes the math easier, you could put that power outside of the radical and take the power last. Now, it doesn't matter either way. In this case, that power of 1 doesn't really change the problem any, so either of those forms is equally as easy. So can you take the cubed root of 8 to the 1st, or the cubed root of 8? And the answer is yes. The cubed root of 8 is a positive 2, because 2 times 2 times 2 is a positive 8. All right, let's look at this problem. 25 to the 1/2 power. Rewrite in radical form. That's the same as the square root. Remember, the denominator is your root or your index of 25, and then that power of 1 can either go underneath the sign, or if it makes the math easier, you could shuffle it outside and take the square root of 25 first. Again, since it's a 1, it doesn't much matter. Square root of 25, remember, you can write that without that index of 2, since it's an understood 2 on that index for square root. Square root of 25 is principal square root, so it's a positive 5 only, because 5 times 5, or 5 squared, is 25. Now let's look at an example where our numerator is something different than 1. Let's say you're asked to simplify 4 to the 3/2 power. Now if you convert that to radical form, that would be the square root of 4 cubed, or the square root of 4 taken first, and then that cubed. Now you could do that either way, and with a calculator it doesn't much matter, but if you're doing it in your head, this form is probably easier because this is a smaller value that you're taking the square root of, and one that you probably know. Doing the square root of 4 first, written like this, using orders of operation, square root of 4 is 2, and then if we take 2 and cube that, 2 times 2 times 2 is a positive 8. Let's do one more example. Let's say we're asked to take negative 27 and raise that to the 2/3 power. Now that's the same in radical form as the cubed root of negative 27 squared. Or, if it makes our life easier, we can shuffle that power of 2 outside of the radical and take the cube root of negative 27 as our first step with orders of operation, and then square it. Now again, with calculators, it doesn't really matter. But if you're doing that by hand, it's much easier to do this step rather than to do this, because negative 27 squared is a very big number. Okay? So the cubed root of negative 27, looking at it in this form, is a negative 3. We can do that in our head. Negative 3 times negative 3 times negative 3 is negative 27. And then if you square that, negative 3 times negative 3 is a positive 9. All right, let's look at a few more examples then. Let's say you're asked to simplify using radical form 9 raised to the 3/2 power. Written in radical form, that's the same as the square root of 9 cubed. Or, if you shuffle that power out, that's the same as the square root of 9 quantity cubed. If you're doing the problem in your head without a calculator, this is the easier way to go. Using orders of operation, simplify in the parentheses first. The square root of 9 is 3. And then if you take 3 cubed, 3 times 3 times 3 is 27. All right, negative 32 raised to the 2/5 power is the same as the 5th root of negative 32 squared. Or if you shuffle that power out, that's the same as the 5th root of negative 32 quantity squared. I'm going to use this form here simply because it's easier to do in my head. The 5th root of negative 32 is negative 2, because negative 2 multiplied by itself 5 times is negative 32. And then if I do the power, negative 2 quantity squared, negative 2 times negative 2 is a positive 4. So what about a to the negative m minus n? What if there's a negative exponent with that fractional exponent? Well, it turns out that that's the same as with other negative exponents. What you learned in previous math classes is that if you have any base and it's raised to some negative exponent, that's the same as taking the reciprocal of that expression, and that negative exponent then becomes a positive exponent. Okay? And the same would be true if you had, let's say, something that had a negative exponent down in the denominator. If I asked you to simplify 1 divided by x to the minus 2, if you take the reciprocal of that, which simply means just shuffle that up into the numerator, that becomes x now to the positive 2. Once you shuffle it up or down, the negative exponent becomes positive, or if you think about it as taking a reciprocal, you flip it over. And then since we have nothing left in our denominator but 1, x squared divided by 1 simplifies to x squared. So it doesn't matter whether that exponent is an integer or whether it's a fraction, that same technique does apply. So let's say that you're asked to simplify this problem. 16 to the negative 3/4 power. First thing you want to do is make that into a positive power by taking the reciprocal. So 16 to the negative 3/4 is the same as 1 over 16 to the positive 3/4, which is the same as 1 over the 4th root of 16 cubed. Or, if you want to shuffle that power out, 1 over the fourth root of 16 quantity cubed, which is the same as 1 over the fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. And then we'll apply that power of 3 to that, which gives us 1 over 2 cubed is 1 over 2 times 2 times 2, which of course is 1/8. So negative exponents work exactly the same as positive exponents, except one extra step. All right, now we need to review from Chapter 5 a little bit all of the properties of exponents, in addition to the negative property that we just reviewed. That's expressed right here. Okay? Because all of the properties you learned prior to this section will also apply to fractional exponents as well as integer exponents. So, for example, if we were looking at this problem, base a to the m power times base a to the n power, you learned in Chapter 5 or in your previous math class that you could simplify that into a single term by adding the exponents, not multiplying them, but adding them. For example, in Chapter 5 we had integer exponents, so you might have had a problem like this. X cubed times x squared, same base, so you can combine that into a single term by adding your exponents, and you get a simplified answer of x to the 5th as a demonstration of that first property. Second property, a to the m raised to the n power is equivalent to a to the m times n. So when you have a power raised to a second power, you can simplify that by multiplying your exponents. So an example of that using integer exponents might be x to the 4th squared. Okay? X to the 4th squared, that's a power raised to a second power, can be simplified by multiplying your exponents, which in this case would give you x to the 8th. Third property, if you have a group, and inside that group there is multiplication, okay? Multiplication in a group, and then that group has an exponent applied to it. You can split that exponent out to each of those factors individually and get an expression where each factor has that exponent attached to it, a to the n times b to the n. So again, for example, let's say you were asked to simplify 2x raised to the 3rd power. Remember that this is an understood multiplication step between the 2 and the x, so you can split that power out to each of those factors individually, which would give you 2 cubed times x cubed, which can then be simplified further. 2 cubed is 2 times 2 times 2, which is 8, for a final simplified answer of 8x cubed. Division in a group is the same way. Notice the relationship between Rule 3 and Rule 4. In Rule 3 we have multiplication in a group. In Rule 4 we have division in the group. Whether you have multiplication or division, if you have a power associated with that group, you can and should split that power out. So a divided by c, quantity raised to the n power, is equal to a to the n divided by c to the n. So for example, let's say you were asked to simplify x divided by y, quantity squared. Okay, you can break that power out to each of those factors individually, which gives you x squared divided by y squared, and in this case that is your simplified form. Property 5 says if you have a to the m divided by a to the n, notice that's a like base. This property corresponds to property 1. Notice property 1 deals with like bases being multiplied. Property 5 deals with like bases being divided. In property 1, we added the exponents to simplify. In property 5, we subtract the exponents to simplify. So, for example, if you had x to the 5th divided by x cubed, and you were asked to simplify, using property 5, that would be x to the 5 minus 3 power, which in this case is x squared. All right, property 6 really is more of a definition, simply saying that if you have any base that is raised to the 0 power, the answer to that is always 1. And that's true whether it's a very simple problem or whether it's a fairly complicated problem. Okay, so if you had 8 raised to the 0, the answer to that is not 0, which a lot of students think, but it's 1. Or if you had something really complicated, say you had x cubed, y squared divided by z to the 4th, but that whole group, or that whole quantity was being raised to the 0 power, the simplified answer to that would be 1. And finally, property number 7, we've already reviewed. The negative exponents simply say, to make that a positive exponent, you take the reciprocal and change the sign of the exponent. So, for example, if you had, let's say, y to the negative 4, by definition, a final answer should never have a negative exponent left in it. You always want to make negative exponents positive exponents for your final answer. Okay? So here, this would be equivalent to 1 over y to the positive 4. Now, if the negative exponent happens to be in the denominator, let's say you had 1 over a to the minus 2, you then can take the reciprocal or flip that term up, okay, which is equivalent to what we did here. Here we took that and we pulled it down into the denominator. Here we're pulling a to the minus 2 up into the numerator, which gives us a now to the positive 2, not negative 2. And also notice that, sticking with this same topic, if you had something like this, let's say a to the minus 2 b cubed divided by c to the 4th power d to the minus 5. In that case, all those bases are different, so you could not combine a and b and c and d in any way because they're different bases. But you can't leave your answer like that because you have negative exponents in that answer. So to get rid of those negative exponents, we're going to take the reciprocal or pull those numerator terms down and pull those denominator terms up simply to change the sign of the exponents for our final answer. As long as this is all multiplication and division, you can move that freely. Okay? And so if there's a factor that already has a positive exponent, like the positive 3 and the positive 4, they'll just stay there and the other two factors will move and multiply on to what's already there. So what we'll get here is the b cubed does not move because it's already positive, but we're moving the d factor up, so that's going to become d to the positive 5, divided by, now down in the denominator, we already have the c to the 4th term, but we're moving the a down, and that negative 2 becomes a positive 2. Now all the exponents are positive, there are no like bases, so we can't combine them, and that would be your final answer. All right, so these properties apply to both integer and rational, which remember is a fancy name for fraction, number exponents. So we're going to apply those properties that we just looked at and simplify the following examples. So let's look at this problem. X to the 2/3 times x to the 5/3. All right, we have like bases, so we can combine that into a single term by adding our exponents. Now, you know when you add fractions, you need a common denominator, which we have. So that's going to be the same as x to the 2 plus 5 is 7/3 power. And there's nothing further we can do with that. We do not want mixed numbers for our exponents. And so since we can't reduce that fraction in any way, that would be our final answer. So let's look at this problem. Let's say we had a to the 1/3 divided by a to the 1/6. Now, those are like bases being divided. So to simplify that into a single term, we're going to subtract our exponents, and it's always numerator minus denominator, top minus bottom. So we've got 1/3 minus 1/6. Just like with adding fractions, when you subtract fractions, you do need a common denominator. So the common denominator here would be 6, so we're going to take that first fraction and multiply top and bottom by 2, which gives us a to the 2/6 minus 1/6, which is a to the 1/6 power, and that is simplest form. Nothing else we can do with that. Simplify this. 2 to the 1/5 times x to the 2/3 times y to the 1/4, that whole quantity raised to the 3rd power. Now we've got multiplication in a group. Look and see, are there any like bases that we might be able to combine using property number 1 by adding exponents actually in our group? And the answer is no, there aren't any. 2 and x and y are all different bases. So what we can do, though, is because we have multiplication in our group and a power that is being applied to that group, we can break that power out to each of those factors individually. If a factor already has an exponent attached to it, that power of 3 will apply on top of it. And so we could write it like this. We've got 2 to the 1/5 was already there, and we're breaking that power of 3 out to that, and so it becomes 2 to the 1/5 raised to the 3rd power. Powers to powers multiply. So our next step is going to be we're going to multiply 1/5 and 3. But to complete writing this, we've got x then to the 2/3 to the 3rd power, and y to the 1/4 exponent to the 3rd. Okay, powers to powers multiply. So now we have 2 to the 1/5 times 3, x to the 2/3 times 3, y to the 1/4 times 3. Since this is fraction work, you know those 3's are all up in the numerator. So now we have here 2 to the 1/5 times 3 is 3/5. X to the 2/3 times 3, notice our 3's cross cancel, so we're left with x squared. And y to the 1/4 times 3 over 1 is y to the 3/4 power. And that would be our final answer. 2 to the 3/5 x squared, y to the 3/4. All right, so let's look at this problem. Let's say we have the quantity 2x to the 1/5, all raised to the 4th power, divided by x to the 3/10. First step, break that power out to each of those factors individually. Don't forget the 2. The 2 is a factor as well. A lot of times students won't break that power out to the constants, only to the variable pieces. It's got to break out to everything. So now you've got 2 to the 4th times x to the 1/5 to the 4th divided by x to the 3/10. Powers to powers multiply, so we're going to multiply there. So we've got 2 to the 4th. X to the 1/5 times 4 is 4/5, all over x to the 3/10. Simplify 2 to the 4th. 2 times 2 times 2 times 2 is 16. And notice that here we have division of like bases. So division of like bases says you can write that as a single base by subtracting your exponents, top minus bottom. So we've got 4/5 minus 3/10. We can get a common denominator here because we're subtracting. So multiply our first fraction, top and bottom, by 2. Now we have 16 8/10 minus 3/10, and 8 minus 3 is 5. So we've got 16 to the 5/10, which reduces to 16 to the 1/2 power. Okay, let's look at more examples. Let's say we were doing this problem. The quantity m squared n, all raised to the 1/4 power, divided by m to the minus 1/2 n to the 5/8. This problem could be approached in a couple of different ways. I am going to stick with the method where we always get rid of those grouping symbols first. So I am going to break out that power of 1/4 to each of those factors. So that would give us m squared, which was already there, now has a 1/4 attached to it. N, or n to the first, is going to have that 1/4 applied to it. And 1 times 1/4 is just 1/4, so I'm leaving off that power of 1 to save myself some writing. Okay. Divided by m to the negative 1/2 n to the 5/8. Okay, we'll simplify this. Powers to powers multiply. So we've now got m to the 2/4, which of course is 1/2, n to the 1/4, divided by m to the negative 1/2, n to the 5/8. All right, I'm going to simplify that 2/4. Remember, 2/4 is the same as 1/2 if you divide top and bottom by 2. And now notice that we have some like bases that are being divided that we can simplify by subtracting the exponents. So we've got, when you subtract exponents, the term that you get after you subtract exponents will always be up in the numerator eventually, or initially. Now, if you end up with a negative exponent after you subtract, you might have to shuffle it down in the denominator, but the first initial subtraction step will always put that base in the numerator as you're subtracting. So m to the 1/2 divided by m to the negative 1/2 is the same as m to the 1/2 minus whatever's in the denominator, negative 1/2 power. And then n, same way, we've got n to the 1/4 minus 5/8 power. 1/2 minus a negative is the same as adding a positive, so we're really adding there. So we've got now m to the 1/2 plus 1/2 is 2/2. And we need a common denominator, so we need a denominator of 8, so we're going to build up that first fraction, which is going to give us n to the 2/8 minus 5/8, which now gives us m to the 2 divided by 2 is 1, so m to the first. N to the 2 minus 5 is negative 3/8. You can't leave your final answer with a negative exponent, so we're going to need to pull that n term down. That's going to give us m to the first, or just m, divided by n to the positive 3/8 as our final answer. You can't combine m and n because they are not like bases. What about this example? 5 divided by 7x to the negative 3/4. You want to be careful on this problem. This problem looks simple, and it is, but many students will miss it because they will not think about what that negative 3/4 exponent actually applies to. Exponents only apply to what's directly to the left of them. And since that 7 and that x are separated by multiplication, you want to recognize that it is only the x factor that negative 3/4 applies to. So when you make this positive, which you have to, the only thing you're going to shuffle up is the x, not the 7. The 7 will stay down in the denominator. So now we've got 5, which was already there, times x to the positive 3/4, because we shuffled it up, divided by 7, which was left in the denominator. Okay? A lot of times students think you shuffle the 7 up as well. That is not true because the negative 3/4 power does not apply to it. So this is the simplified form of that problem. What about this problem? Quantity x cubed y squared raised to the 1/4 power divided by x to the negative 5th, y to the negative 1st, all raised to the negative 1/2 power. There's a lot of negative exponents there, and often students want to try to clear out all of the negative exponents first. You can work this problem like that, but it's a little more complicated because people aren't sure what to do with the grouping symbols. So my recommendation is don't worry about the negative exponents until the very end, and then in your final answer, shuffle stuff around if you need to. Otherwise, all your properties of exponents work for positive numbers, negative numbers, and fraction numbers as exponents, so use your properties first. So we're going to split out that 1/4 power and split out that negative 1/2 power to each of those factors, since we can't combine the x's and the y's together because they're different bases. So we've got x cubed, which was already there, to the 1/4, times y squared, which was already there, to the 1/4, all divided by x to the negative 5th, raised to the negative 1/2, and then y to the negative 1st, all raised to the negative 1/2. Powers to powers multiply, so our next step is a multiplication step. So we've got x to the 3 times 1/4 is 3/4. Y to the 2 times 1/4 is 2/4, which of course will reduce to 1/2. Divided by x to the negative 5 times negative 1/2. Negative times negative is a positive. 5 times 1/2 is 5/2. And y, negative 1 times negative 1/2 is a positive 1/2. So notice that without moving things around, it turns out that all our negative exponents cancel themselves out, which is nice. So now we've got some like bases that are being divided, so we need to subtract exponents. So we've got x to the 3/4 minus 5/2, y to the 1/2 minus 1/2. That's the same as, we need a common denominator here. So if we build this second fraction up by multiplying top and bottom by 2, we've got 3 minus 10 divided by 8. 3 minus 10 is negative 7. So we've got negative 7/8. Y to the 1/2 minus 1/2 is 0. You know that anything to the 0 power is 1, so that's multiplication by 1. And you also can't leave that as a negative exponent for your final answer, so shuffle it down. And that leaves us with 1 divided by x to the positive 7/8 for our final answer. And I didn't really leave enough room to do a 4th example on this page, so we're going to go on to the next page. For our final topic, converting radical expressions to rational exponents can help simplify radical expressions. The instructions, therefore, are to convert any simplified answer back to radical form after using rational exponents to simplify the following. So let's say that you're given this problem, the 6th root of x cubed, and you're going to use rational exponents to simplify that. The 6th root of x cubed, written in rational form, is the same as our base, x, to the power is our numerator, and the index or root is our denominator, so x to the 3/6 power. 3/6 is a fraction that can be reduced, so if you reduce that by a factor of 3, that's the same as x to the 1/2 power. And then convert that back, because the original problem was in radical form. That's the same as the square root of x to the 1st, or to clean that up further and leaving the 2 off since it's an understood square root of x as our final answer. Let's look at the 4th root of 36. Okay. 4th root of 36 is the same as the 4th root of 6 squared. Okay. And that is the same as 6 raised to the 2/4 power, written in rational exponent form. That's a fraction that we can reduce. 2/4 is the same as 1/2, and that is the same as the square root of 6 to the 1st, or in simplified form, the square root of 6. All right, let's look at this problem then. Let's look at the 12th root of a to the 8th. 12th root of a to the 8th is equivalent to a to the 8/12th power. There is a common factor there of 4 that we can take out. So that's equivalent to a to the 2/3 power. And that will convert back to a squared underneath our sign, and we're taking the cubed root, or if you prefer, that's the same as the cubed root of a squared. Probably this is considered more simple than this simply because we don't have extra parentheses in that problem. So that brings us to the end of Module 16, Section 10.2 material. And you should now complete the homework for Module 16, Section 10.2, found in my math lab. When you have successfully completed that homework, proceed to the video for Module 16, Section 10.3.